Hi, I am Keder Mallick.
This is Purnadip Manna.
Hello, this is Arghya Sahoo. In this video, we will be talking about an automated smart assessment system which we believe will greatly improve education quality.
Nowadays, there are a lot of e-learning platforms which provide good quality learning materials. The combination of videos and reading materials make up a pretty good learning experience. But one major drawback in all of these platforms is lack of clever assessment techniques. Almost all of the platforms use MCQ type questions to assess a learner, but this technique is not really up to the mark in online assessment. In this method, there is a very little scope of tracking brilliance and analytical skill of an individual learner. MCQ-based assessment has quite a few notable drawbacks, one of which is restricting creative answers. Multiple choice questions tend to confine the answer within a limited set of options and provide no room for individual creativity. During the assessment, learners are able to see all options at once along with the question, which in turn gives a very little time to think about the problem itself. Often the option confuses a learner rather than uplifting his analytical skills. Which brings us to another major flaw of the system. It is very easy to cheat or guess answers in MCQ-based online assessments. This malpractice is harder to detect and leads to erroneous evaluation. MCQ-based assessment only covers the first level of Bloom's taxonomy, which is memorizing. Essentially, just memorizing facts without understanding them properly can lead to a pretty good score in this type of assessment. It also does a poor job of evaluating a learner's understanding and analyzing skills.
Now we are going to talk about a survey conducted by us where we put out some points from Bloom's taxonomy and asks people to rate their effectiveness for MCQ and SAQ questions on a scale of 1 to 5. We gathered over 200 responses in the survey. Almost 44% of the people who responded are teachers, 55% are students and 4% are guardians. The survey results were rather astonishing. In some of the cases, students preferred MCQ questions with a higher rating, whereas teachers and guardians preferred SAQ questions. In the first question, we asked which method of assessment is more effective while evaluating a student's knowledge level. Here, 71% of the students and 36% of teachers were choosing MCQ, whereas 55% of the students and 83% of the teachers are choosing SAQ over MCQ. Our next question was which method of assessment is more effective while evaluating a student's practical knowledge about the subject. In this case, 61% of the students and 24% of the teachers were choosing MCQ, whereas 88% of the teachers along with 75% of the students prefer SAQ over MCQ. Then we asked which method of assessment is more effective while evaluating a student's analytical skill. And here 69% of the students and 33% of the teachers are choosing MCQ over SAQ, whereas 50% of both teachers and students are preferring SAQ. Lastly, we wanted to know which method of assessment would be more effective while evaluating a student's core knowledge. Here we found that 63% of students and 28% of the teachers are choosing MCQ over SAQ. By contrast, 52% of teachers and 59% of students prefer SAQ over MCQ. In our survey, we found that 70% of the teachers have found that answers to subjective questions can be divergently expressed, while 46% of students have found MCQ questions easier to answer.
Next, we will be talking about the objective of the solution. We propose a solution that can eliminate aforementioned problems and make the assessment even more versatile. Our solution suggests including subjective questions along with the MCQs to the online assessment. Firstly, this makes guessing or cheating in assessment a lot harder. Even if that happens, it will be easier to detect just by comparing both answers. Also, subjective questions allow the learner to carefully construct an intelligent answer, which reflects their concept on that subject. By clever construction of questions, a student can be properly evaluated based upon his knowledge, understanding, and analytical skills, which falls under metrics of Bloom's taxonomy. Also, a learner will be able to self-assess himself through this system. The questions will be divided into multiple difficulty levels, which will make a learner understand his level of knowledge and motivate him to get better at it.
We try to overcome aforementioned problems with as little manual effort as possible. One of the major hurdles towards achieving our goal is to manually check the answers of subjective questions. This task sounds almost impossible due to massive student traffic in e-learning platforms. So we implemented an automation system for subjective type examinations. This can greatly reduce manpower as well as prove to be very effective towards assessing students online. In order to make it work, the assessor has to provide a standard answer for each and every question. The learner's answer will be compared against this to match the similarity between them. With this, the relationship between two sentences can be extracted. There can either be entailment, neutral, or contradiction. Entailment means if sentence A entails sentence B, sentence A cannot be true without sentence B being true as well. Contradiction means if sentence A contradicts sentence B, sentence A and sentence B are meaningfully and contextually different. Neutral means sentence A and sentence B have no defined relationship between them. This semantic similarity is the first step of our solution. Next, we will be extracting keywords from the standard answer as well as the learner's answer. The keywords will be matched against each other and based on which a score will be generated. This technique will work even if the learner represents his answer differently from the standard answer. As long as the answer is correct, the learner will get a good score.
Now we'll talk about the methodology of our proposed solution. We divide our approach of evaluation in two steps. Firstly, we find the semantic similarity of the student's answer with the standard answer. In order to do so, we have to first encode both answers to convert them into vector representation. For encoding here, we are going to use a transformer-based embedding system called BART, bidirectional encoder representations from transformers. BART is a patent model built by Google and uses an attention-based mechanism to encode the input. In our case, we are going to use BART-based uncased model. First step of this process involves collecting the answers given by the student and converting it into batched data along with the standard answer. Next, the batched data will be tokenized for preprocessing. In this step, a few extra tokens like CLS, separator, padding, etc. will be added with other tokens. This tokenized data will be fed into the BART preprocessor, which will return input IDs, means if the input is present in the predefined dictionary of BART tokenizer, it will return an ID according to it. Attention mask, which will use denoting the padding token, and token ID types, which is used for denoting string position. All of these will form the pretend BART model, which will return an encoded tensor. Now, to extract the sense of the answer, we are going to introduce a simple classification model along with the pretend BART model. This will generate the fine-tuned BART classification model, which will be able to semantically analyze the output. Our approach towards evaluating a student's answer is to find semantic similarity with the standard answer. Our model will be successfully able to predict senses like entailment, contradiction, or neutral sense. Based on the output of the student will be graded. The BART model can be fine-tuned. After being trained by our custom data, we can load the pretend weights of the actual model and it will increase the accuracy precisely. The second part involves matching keywords between standard answer and learner's answer. For this task, we use KeyBART, which is a minimal and easy to use keyword extraction technique that leverages BART embedding to create keyword and key phrases that are most similar to a document. These extracted keywords are fed to distill BART NLI mean tokens model for embedding. Now, to check similarity between both answers, few similarity and distance metrics are used. In our case, cosine similarity along with Euclidean distance and Manhattan distance metric is used. From the result, maximum match between both answers are selected and the mean is calculated amongst them to get final result. We will also find the Jaccard distance between all keywords from the sentences too.
This is the prototype of our proposed solution. Initially, a user need to sign up to create an account. Then they can log in to their respective accounts. By default, all the user will be recognized as a student by the system. Only the admin can set users as teachers. After logging in as a teacher, user will get a button to create a new exam. Upon clicking on the button, they need to fill up the necessary details for the exam. Then they can set questions and answer. Teachers are free to edit, delete and update questions during creation. Hitting the final submit button, the exam will be created, which they can view on their dashboard along with all the students. As a student, after logging in, they will be able to view a list of all upcoming exams in their dashboard. They will be able to attempt all the examinations. Upon clicking on attempt, students have to take a photo in a well-lit room where their face is clear visible. Then they will be redirected to assessment page where they will be able to view the questions and answer them. They are also free to edit their answer along the way until they want to final submit their answers or the times runs out. After a certain period of time, the teacher can evaluate the examinations and the answer will be automatically evaluated by our models. And teacher as well as students can check their results.
In case of monitoring during examinations, a student monitoring system can be introduced. The monitoring system will initiate its task by taking an examinee's face as input and match it with the live video feed during the entire examination. Along with this, the screen switch detection mechanism can also be integrated to make the examination process even more secure. This will prevent an examinee from switching tabs during the examination. For self-assessment, the questions will be grouped into 3 difficulty levels: easy, medium, and hard. An automated system will assess the learner based on these 3 difficulty levels. If a learner successfully answers a question from a level, he will be promoted to the next level without having to attempt any of the questions from the same level. For instance, if a level has 5 questions in them, upon taking the assessment, a learner will face an easy question. If he manages to answer that correctly, he will be promoted straight to medium level questions and will not have to attempt the rest of the questions from easy level. But if a student fails to answer a question at any level, he will be stuck in that level until his performance gets better. This system can prove to be very efficient for performance analysis of a learner. We also plan to introduce automatic question and answer generation from a given passage. This will greatly reduce the teacher's effort while setting up the questions. Generating automatic answers as well as having the flexibility to set questions manually will be greatly effective while setting an exam. Last but not the least, the entire assessment will be gamified for the student, which will help them to perform better and work as a constant motivation. By adding skill levels, reward system will greatly motivate a student to gradually score better in assessments. As mentioned earlier, MCQ questions hold back a learner from thinking out of the box, instead forcing them to write within the options. Our system respects individual creativity and motivates analytical thinking. Here, learners will get a chance to show their individual brilliance. Answers curated with individual brilliance of a learner can be properly evaluated using Bloom's taxonomy. Unlike MCQ questions, these type of answers have unique word formations and concept representations, which reflect a learner's own grasp of the subject, which indicate a student's knowledge, ability to comprehend and apply concepts, analysis and synthesis skills. Our proposed solution will include a self-assessment system which assesses a learner based on their individual skill set. If any learner is unable to answer any question of lower level, he will not get any question from higher level. Unlike the traditional systems, instead of holding them back, this method will be motivating students to gradually perform better. Gamification of the assessment system will not only attract more learners to appear in assessments, but also motivate them to perform better. Providing different badges and perks, introducing different skill levels, setting up daily goals will play a major role in uplifting a learner's willpower to gradually perform better. Overall, it will make the whole learning process filled with amusement and joy.